Okay, so this next video talks about data displays, pie charts, bar graphs, histograms, and line graphs. So again, different ways that we can display data. We've got to be familiar with how to read these different data displays and pull out key information from each one. So let's start with a pie chart. So this is a special chart that uses pie slices and percents to show relative sizes of data. The entire pie must total 100%. So we're talking about percent here. The entire circle is 100%. You can kind of break things down from there. So this is an example. Use the pie chart representing waste in 2011 to answer the questions below. What percent of waste was paper? So if we look at this pie chart, find where it's paper, we can see here's the paper, and it tells us 15% of the waste was paper. If there was 1,000 tons of waste tracked in this chart, how many tons were food? So again, we find where the food is. Here's food. And so it says 21% is food. We need to remember that if we do 0.21, 0.21, we have to get the percent to decimal. So we move it 2 places to the left and multiply it by the total. Remember, of represents multiplication. Then I'm going to figure out when I multiply those 200 tons of 1,000 tons of waste was food. So if it's asking you for something like that, so like this is the total, find the percent of this total, we need to turn it into a decimal and multiplication. Let's check out another example of pie charts. Okay, so here Anna did a survey where she asked all the children in her school to name their favorite pet. The results are shown in their pie chart, in the pie chart. So notice we've got 800 children in the school. How many students said their favorite pet was fish? So if we find fish, notice there isn't a percent for fish, but we know the total here is supposed to be 100. So let's just do a little side calculation to figure out the percent of fish. We need to subtract all of these from 100. So I'm going to start with other. 11 minus 8 minus 36 minus 28 minus 7 minus 6. And when we do that, we get 4. So this is 4%. Now to answer the question, how many students said their favorite pet was fish? I can't say, well, yeah, sure, 4% said it's fish, but how many students? We need to take this to a decimal. So it's 0.04 times the total students. This is just like the one we did above. And then we're going to get 32 students out of 800 said fish was their favorite pet. Okay, so a little multiplication there. How many people said their favorite pet was a dog? Well, hopefully everybody, because we all love dogs. We've got 36% for dogs. So I'm going to take that percent, turn it into a decimal, multiply it by the total, and we get 288 people said dog was their favorite. And now 56 people said their favorite pet 56 people said their favorite pet was what? So 56 out of 800, that gives us what decimal? 0.07. If I do that division, if you type into a calculator 56 divided by 800, you'll get 0.07. As a percent, that's 7%. Move it 2 places to the left. And then 7% is what pet? Rabbit. So that's just taking it the other direction, the other way. Okay, so that's some information about a pie chart. Let's learn about a bar graph. So bar graph displays sets of data using bars of different heights, usually used with qualitative, non-numerical categories. So notice these categories aren't numbers, they're topics. Favorite type of movie, we've got comedy, action, romance, so on. So they're not numbers for a bar graph. How many people in the survey preferred movies that were comedies? So if we go to comedies, go up, we can see 4 people prefer movies. How many total people were surveyed? We've got to see how many are in each bar. So I've got 4, 5, 6, 1, 4, using the bars on the left here. And then we're going to add that up. 4 plus 5 plus 6 plus 1 plus 4. That gives me 20 people total. Bar graph versus a histogram, okay? Because notice they look very similar, right? So what's the difference here? Histogram displays sets of data against ranges now. So this is interesting, using bars of different heights, usually used with quantitative. So now our categories are numbers. And the bars must touch for a histogram. Notice these bars don't touch in between. Histogram, they do touch, and that's important. Okay, so how many, but we read it the same. How many trees measured between 150 and 200? So this is 100 and this is 150. So in here could be 120. Okay, so if we want 150 to 200, we are looking at this bar, and that's 30 trees. How many trees measured above 250? Here's 250, and we want everything above it. We need these two bars. And so this is going to be 50, and this is going to be 11. Does it look like it's a little over? So I've got 50 plus 11 gives me 61 trees. How many total trees were included in the survey? So we can say this is about 4, 30, 26, I want to say, 50, and 11. And then we'll add them all up. 4 plus 30 plus 26 plus 50 plus 11. We get 112 trees total. Okay, just watch. This is more of a range. So this is from 100 to 150, 150 to 200. So just be careful there. Let's practice. So here's the difference between bar graphs and histograms. We've got gaps in bar graphs, no gaps between the bars and histograms. Here we've got ranges. Here we've got topics, categories. Okay, so just be careful there. Let's look at some examples of a bar graph. So the bar graph shows the scores obtained when a die was rolled a number of times. So notice I roll a dice. We've got the number 1, 2, 3, 4, 5, 6. These topics, right? If I roll a 6, how many times? And that's what this is. The frequency I rolled a 6, or the frequency I rolled a 2. What is the mode of the data? So what we need to do to find the mode is the one that occurs most often, and that's the highest bar. The one that occurred most often, that's a 2. How many times was the number 4 rolled? If I go to 4, this says it's about 3 times. We're going to round up because we can only roll whole numbers. How many total times was the dice rolled? So I've got 2, 6, 1, 3, 5, and 3. So I've got 2 plus 6 plus 1 plus 3 plus 5 plus 3, 8, 9, 10, 11, 12, 17, 20 times. Okay. And then let's check out an example of a histogram right here. So histogram, we've got ranges. See how we've got ranges, not topics, and the bars are touching. How many babies weighed 8 pounds or more? So if I go to 8 or more. So I've got, these are tiny. 22, 16, 6, 1. So actually this one might be 15. Yeah, so 22 plus 15 plus 6 plus 1 gives me 44 babies. How many babies weighed between 5 and 8 pounds? So here's 5 and 8 pounds. We've got 8, we'll say, 15, and 30. 8 plus 15 plus 30 equals 53. And then what is the potential range of baby's weights? So the greatest was 12 and the least was 4. So our potential range is 8. Okay? So the last data display that we are going to talk about today and this week is a line graph. A line graph is used to show information that is linear in some way, such as changing over time. So use the line graph to answer the questions below. This graph is facts I got correct. I believe that says like day number and then how many facts. So day 1, day 2, day 3, day 4, how many facts I got correct. Maybe learning a new topic. How many facts did this person get correct on day 2? So if we go to day 2 and where it meets on the graph, 4 facts. Is this person improving or getting worse in the number of facts correct per day? So as the days progress, the facts are increasing, so they are improving. Because we are going in a positive direction, positive slope. Let's tie that back in with slope. And then let's check out one example of line graphs. Okay, so Jerry recorded the temperature in his room in degrees Fahrenheit every 2 hours. So we've got from noon to 2, 4, 6 p.m. and so on. The results are shown. What was the approximate temperature in Jerry's room at 9 p.m.? So if we find 9 p.m., it's around here, go up to the bar graph, and then I've got to go over. That's about 30 degrees Fahrenheit. Okay, let's erase that and check out the next problem. At what time was Jerry's room approximately 25 degrees? So here's the temperature. I go to the side. 25 degrees is here. What time was that? 10 p.m. And then the next question. At what time does the temperature start to decrease? So notice the temperature is getting warmer and then it's decreasing. Check out our slopes. Check out the numbers on our y-axis. And that's about at this time, which is about at 4 p.m. Okay, so that is just some practice with reading line graphs, bar graphs, histograms, and pie charts. Great job, guys. These are all different ways we can display data.